All right, guys, we're moving into a new unit of solving quadratics. Quadratics are anytime you have an equation that involves an x squared and not anything higher. So we're not talking about those big GCF questions, but more the trinomial questions. And we're going to visit this a lot. But that's kind of the quick introduction is we're looking at x squareds now. We're also getting back into solving. So just to kind of remind you, I took a really easy example here. We've solved these all year long, where you minus the 7 first, then you divide by 3, and you end up with an answer of x equals negative 5. Now, one thing I want us thinking about is the reason we subtract 7 is because we're using inverse operations. The opposite, the inverse of adding 7 is to subtract 7. That's how I get it to cancel out. I do it to the other side. The inverse of multiplying by 3 is to divide by 3. They cancel out, and I do it to the other side. The reason we do the addition and subtraction first is because when we're solving, we're working backwards. So you're actually doing PEMDAS, but you're starting at the back, and you're going to do the addition and subtraction step first. Then you're going to do multiplication and division. And in this problem, that's all there is. There's not any other steps happening. To think about what this solution actually means, remember, it's if I was to replace that x with a negative 5, so 3 times negative 5 plus 7, I get negative 15 plus 7, and negative 15 plus 7 is, in fact, negative 8. It is the only number that I can plug in for x that when I work out this whole problem, I end up with negative 8 like I should. Okay, so just to remind you how solving works. Well, if I give you an equation that's a quadratic, it has x squared equals 25. This is about as easy, simple of a quadratic as you can get. I'm solving, so I'm still looking for what does x equal. And most of you are pretty good. You pretty quickly come up with, oh, so x has to be 5. What you did without realizing it is you actually did an inverse operation. The inverse of squaring something is to take the square root. Just like here, adding 7 and subtracting 7 canceled each other out. Well, here, the squared and the square root cancel each other out, and it doesn't cross out very nicely because of kind of where they go. And then I'm going to do it to the other side, and the square root of 25 is 5. But here's where quadratics get tricky. That's not the only number that will work when I do 5 squared, it equals 25. That's not the only number that will equal 25 when I plug it back in. If you think about it, it could also be a negative 5, okay? Because think about it. If I did negative 5 squared, negative 5 times negative 5, it also equals 25. So it's kind of an added thing that quadratics, because we have this square root situation, usually, I can't say always, and we'll talk more about why later, but they usually have 2 solutions, okay? Because like I said, it's not only a positive 5 that's the only number that works. Negative 5 will also work, okay? All right, so if I add on a step here and I say x squared plus 3 equals 52, I'm going to use that same process, that same PEMDAS inverse operation. I'm going to start at the back. So I'm going to do the addition and subtraction first. I need the inverse of adding 3, which would be to subtract 3. That leaves me with x squared equals 49. And now I don't have any multiplication or division, so the next thing I go to is the exponent. And we just said, well, the inverse of squaring something is to take the square root. And just like here, you subtracted 3 because it was the inverse, and you also did it on the right-hand side. I took the square root because it's the inverse. I'm also going to do that on the right-hand side. So I get x equals 7. Or remember, we also have negative 7 because 7 times 7 is 49. Negative 7 times negative 7 is also 49. Mathematicians are lazy. They don't like the fact that they would have to write a 7 twice. So what you will see them do a lot of times to show both of these answers is you will see the notation plus minus 7. That's not a fancy new number. All it is, oh, I want a positive 7 and a negative 7, and I don't want to write 7 twice. So it's just a shortcut to write it so that you're not having to always write a number over and over again. If I go with 3x squared equals 300, I'm going to do my PEMDAS because I'm going backwards. So in this case, I don't have any addition and subtraction happening. I'm going to do the multiplication and division inverse. The inverse of multiplying by 3 is to divide by 3. So I end up with x squared equals 100. Take the square root of both sides, and x is just plus or minus 10. A positive 10 and a negative 10. That is actually two different answers that I'm giving there. There's two solutions, not just one. All right. If we go with 2x squared minus 13 equals 37, it's the same basic concept. I'm still using PEMDAS, so I'm a math person. I don't want to rewrite stuff. I'm just going to use this one up here. Addition and subtraction first means I would inverse with a plus 13, which means 2x squared has to equal 50. Now I would move to the multiplication and division. So I'm going to divide by 2, which gives me x squared equals 25. And now I'm going to move to the exponent. So I'm going to square root them. And I end up with x equals positive or negative 5, which is the same as writing 5 or negative 5. And then if you remember back from the beginning of the year, it was a while ago. Oh, sorry. You can also write that with a list, 5, negative 5. Remember we said if you have an answer that's a list, you'll sometimes see it in those curly brackets just as showing, oh, that's the list of all of my possible answers, okay? So it's exactly the same PEMDAS that we've used. It's the exact same inverse operations that we have used. The only difference is before now, we really have only seen addition, subtraction, multiplication, division. We never really saw exponents. We'd occasionally see parentheses, but not exponents. So let's kind of throw a couple things in here, because here's where it can get confusing, is when I have the problem parentheses x plus 3 squared equals 16. I've had a lot of people today that have argued or wanted to say, oh, well, that is just x squared plus 9 equals 16. Okay, I get why we are thinking that. We want to distribute the squared. That is wrong. No, don't do that. That's like angry. Don't do that, okay? That's an angry face. That is not how this works. What this actually means is x plus 3 times x plus 3, okay? And if you were to actually set up a box and work this out or use FOIL, you would end up with x squared plus 3x plus 9. That equals 16, which ends up being this really weird trinomial nasty problem that equals 16, and you're going to have to figure out what number equals 16. We're going to look at this more next week. It's not a fun situation, but there's an easier way. I'm just going to use PEMDAS, okay? I'm going to solve it exactly the same way that I had, but here's the issue. Normally, I would do the inverse of adding 3, right? That adding 3 is trapped inside parentheses being squared. So all of a sudden, I'm not going to use it there in PEMDAS. I don't have any multiplication division. That addition and subtraction has jumped all the way back to being within parentheses. So I'm actually going to do the exponent first if I'm moving across this thing. So what's the inverse of squaring? It's to take the square root. So the square and the square root cancel each other out, and I get x plus 3 equals, the square root of 16 is 4 or negative 4. And I'm not going to use this little shortcut, the plus minus thing, because I'm not done doing math yet. I still have to subtract 3. And I'm going to have to be very careful that I'm subtracting 3 from both of my answer options, okay? So I've got to subtract 3 from the positive 4, and I have to subtract 3 from the negative 4. I'm doing my inverse with all my possible options. So I actually end up with x could be a 1, or over here I get x could be a negative 7. I end up with 2 completely different answers, okay? They don't seem connected at all, but let's check them. So if I test out the 1, I'm going to use this formula, this x plus 3 squared, and I know it needs to equal 16. So let's plug in a 1 and see what happens. 1 plus 3 squared, well, 1 plus 3 is 4 squared, which makes 16. So the 1 totally works. I just proved it. Now, I'm going to move and use the negative 7. So I'm going to say, okay, negative 7 plus 3 squared, and I need this to equal 16, just like the 1 did. Well, negative 7 plus 3 is negative 4 squared, also equals 16. Okay, so it's kind of weird when you take the square root first, because you still have steps you need to do after you've gotten that positive negative. So I'm going to make a little note to myself. When you take a square root early, separate the two options. That way, when you go on and do the later steps, you have 2 separate answers that you're working with, okay? You don't have to do that when you're doing the square root at the very end, because once I get positive 5 and negative 5, I don't have anything else I have to do. It just is bad whenever you have additional steps after that. So I'm just going to do one more example just so that we're totally clear on this and good. But if I end up with x minus 6, oh gosh, it helps if I write the problem right. X minus 6 squared equals 144. All right? Again, if I think about the PEMDAS thing, exponents come before what's inside parentheses. So I'm going to square root to do the opposite of squaring. The square root and the square cancel out, and I get x minus 6 equals 12 or negative 12. I'm going to separate them as 2 separate answers here, because now I still have to add 6. I still have to do the inverse of subtracting 6, and I've got to add 6 to both of my answer choices. So we actually end up with 18 or negative 6. All right. Notice that all the problems have worked out nice and clean. This is a wonderful gift. That will not always be the case, but we will get to those later in the week, okay?